Hey guys, welcome back to Consistent Code. So today's problem of the day is smallest sum contiguous subarray. The problem statement is as follows: that we are given an array ARR of n integers. We need to find the contiguous subarray containing at least one number which has the minimum sum and return its sum. For example, if the array is this, then the output will be -6, because we can see that if we choose this array -3, -1, then +7, and then -5, then this should result in a sum. Sorry, not this one, this one, -4, 2, 3, and -1. This should result in a sum of -6, and this will be the minimum sum which is possible in any of the subarray which we can get from this array. Similarly, you can check out this example in which we are given in which the array elements are all positive. So obviously the minimum sum will be the minimum element 1. So if you are familiar with Kadeen's algorithm, then this should be an easy problem for you. This is a variation of Kadeen's algorithm. So if you don't know about Kadeen's algorithm, you don't need to worry. I will make you understand the algorithm. So first of all, since we need to find the minimum sum, so minimum, if we are adding something, suppose I'm initializing the sum as 0, then this sum will be reduced only if I add negative elements to it. So first thing is, I need to check if the array contains any negative elements or not. So if the array do not contain negative elements, obviously the answer will be the minimum positive element. So first let me check the minimum element of the array. So that will be minimum element of array dot begin to array dot end. So now if this minimum element in the array is greater or equal to 0, that is, if it is positive number, then this becomes our answer. Because if we add any positive element, because if the minimum element of the array is 0 or greater than 0, then this means other elements will definitely be positive, and if we add any of them, then our sum will increase and we need to minimize the sum. So we can simply return mn if the minimum element of the array is positive. So now let's move on to the case when negative elements are present in our array. In this case, we will follow the Kadeen's algorithm, which is like this. Suppose if we consider this example, let me show this to you in here. This is our example. Let me increase the size. So this is our example. So suppose I take this 3, then suppose we are at index I equals to 0. So this is index 0, this is 1, and so on. So if I start at this line, the x-axis is index I and the y-axis is sum, initially the sum will be 3, and then the sum will be added by -4, so the sum becomes -1 here. This is -1. Now if I add 2, then this will again become positive like this. Then if I add -3, it will again become -1, and if I add -1 to it, then this will become more negative, and then if I add 7, then this becomes positive again, something like this. And then if I add -5, it comes down like this. So this becomes the graph of this. Now we need to deal with only the negative elements, because we want the minimum sum. So since we want minimum sum, we need to check only the area below which is having negative sum. Why we are doing so? Well, wait a minute. We need to only check this area. Why? Because we want only the negative sum. For example, if I choose this positive area, then that will only reduce my negative sum. So I do not need to consider the positive area. And if I consider this negative area, like if I start from here, then this will be positive and this will be negative. So if I add them, then this positive part will reduce my negative sum. So I will only choose this negative sum to increase my answer. Then when I move on to this positive part, then I will see that my negative sum gets reduced as it becomes positive. So I will neglect this positive part. And so what we are going to do, whenever we find a negative, we are getting negative sum, we will keep track of that negative sum and we will take a variable which will store the maximum negative sum which we can achieve. And as soon as it gets positive, we will make a negative sum as 0 and we will again keep tracking the negative sum and we move here when we are again at negative sum. So when we reach here, we will get again a negative sum and this will be the maximum negative sum here, and this will be our answer. So I hope you understood this explanation. This is basically Gideon's algorithm. And here, if we were asked to have maximum sum, then we would have considered only the positive part, like this part. But since we are asked the smallest contiguous sum, we will be considering only the negative sum areas for checking the minimum sum. So now let's code this thing out. So what we need to do, we can just start our loop from the array I less than n and I plus plus. So basically what we are doing, we are starting our loop from the first index and we will find the first negative element, because we have already made sure if it only positive elements are present, we have already returned the most minimum element as the answer. But since negative elements are present, then we will find the most contiguous negative sum and that will be our answer. So if it is a positive element, we will not care and we will find a negative element. So we will move to -4 and then we will see if a contiguous negative element is present. So here only -4 is there, so our negative sum will become -4. Then we will move on to 2, and now since the sum becomes here it was 3, so it was not negative sum, so we removed it, and our negative sum started with -4, so we started our contiguous sum from here. Then we will add 2, then our negative sum becomes -2. So we are still in negative sum, so we will continue. Then we will move on to -3, so our negative sum becomes -5. Then we move on to -1, our negative sum becomes -6. So till this area we are getting negative sum only. Now when we move on to 7, our negative sum converts into positive sum of 1. So we will drop this sum here and we will mark this -6 as the maximum negative sum so far, and we will continue to the next point. So then we will go to -5 and we will again start tracking the negative sum. So now the negative sum will be -5, but since this is not greater than the previous negative sum, so -6 will become our answer. So let's code this out. Here we can initialize the sum as 0 and we can say that if this AI is negative, then only we will start tracking our answer. So if this is 0, you can just say we will increment this a of I, the negative element, and we will keep tracking this until the next element is negative. So we can say while I plus 1 is in the bounds of array and the next element, or sum plus a of I plus 1, if we add the next element in our sum, then also our net sum is negative only. Then what we can say is that we can add that element in our sum, and we can take mn as our answer as minimum of its previous value, and thus current sum. And then we can also move the index to the next place. So after this, what we will do, we can then this minimum element after completion of this complete for loop should store the most the minimum contiguous negative sum in this array. So we can simply return this mn. So let's try compiling and running this code. We're getting an error. Okay, n was not declared in the scope, so let's declare it. A dot size, and now let's compile and run this code again. So it's giving the correct output. Let's try the example test case. And now let's submit the code. And we have solved the problem successfully. So I hope you liked the explanation, and if you did, please like and subscribe to the channel, and I will see you next time.